Hello everybody, this is Math 10 A and W with Mr. Sandhu, and we are starting Chapter 1, and I'm going to cover example number 1 on page 10. This is the first example of the workbook in your Mathworks workbook. So what they're asking us to do is simplify 18 over 27, and they're suggesting in their first solution that we use the greatest common or largest common factor to reduce the top and the bottom by the same amount. That will reduce this fraction into something that looks a little easier to understand than the 18 over 27. There is a simpler form. So first and foremost, they're saying let's use this greatest common factor. So we have to identify what is the greatest common factor. Well, I'm going to first factor the 18 and then factor the 27, and then we'll be able to see which one is the biggest factor that they both share. So let's take 18 and factor it. 18 is a product of 1 times 18. Let's go to the number 2. Yes, 18 is a product of 2 times 9. 18 is a product of 3. We're using the counting numbers on the left-hand side here just to walk our way up the counting numbers to see if they work. So 3 times 6 is 18. Now 4 does not go into 18. 5 does not go into 18. 6 does go into 18, but 6 is already written down. So that means, since it's already written down, we're done. We've got all of the factors of 18. Now, if you weren't sure if a number went into 18, you simply take 18 and divide it by a number, like 4. Does 4 go into 18? So 18 divided by 4 is 4.5. So it does not go in as a whole number, even number of times. So it is not a factor. 4 is not a factor of 18. All right, let's do 27. So 27 is a product of 1 times 27. 2, no, 2 does not go into it. This is not an even number. So we're counting up the counting numbers, but we're only using the ones that work. How about 3? 3 does go. 3 goes into 27 9 times. Okay, 4 does not go in, 5 does not go in, 6 does not go in, 7 does not go in, 8 does not go in, 9 goes in, but 9 is already here, which means we're done. Good, we have identified all of them, so let's take a look and see what is the greatest common factor. It looks like the number in both lists, that's the biggest, is the 9. So 9 is the greatest common factor, or the largest common factor. Some people will call it the GCF, greatest common factor, is 9. Let's use 9 to reduce 18 over 27. So first of all, we need to make sure we divide the top and the bottom by the same amount if we want to reduce a fraction. Let me prove that to you over here. If we have 20 over 10, 20 over 40, let's use that, it's easier. If we have 20 over 40, we can see that that's half, right? 20 over 40 is a half. Let's reduce the top by 10 and see what happens. So reduce the top by 10 by dividing it by 10, and 20 divided by 10 is 2. If we don't do anything to the bottom, we'll have 2 over 40. Now that's totally a different amount. 20 on 40 is half. 2 over 40 is nowhere near half. So we can't do that. But if we divide the bottom by 10 as well, in our reduction, then 20 divided by 10 is 2, 40 divided by 10 is 4. Now that looks correct because 2 over 4 is a half, 20 over 40 is a half. So that just proves to you guys that if you're going to reduce a fraction, you have to divide the top and the bottom by the same amount if you want to make sure that these two fractions remain equal in their amount. So let's go back to our question. 18 over 27 is going to be reduced by the greatest common factor. So let's divide the top by 9. Let's divide the bottom by 9. And the result is that 18 divided by 9 is 2. And 27 divided by 9 is 3. So we have 2/3. Good. So let me see here. Is 18 over 27 the same value as 2 over 3? Well, it's hard to tell by looking at them, so what you can do is you can test it. Let's turn this into a decimal amount, and let's turn this into a decimal amount and see if we have the same value. So this question is done, people, but let's just check our work here. So 18 over 27 can be written as 18 divided by 27, and that equals, so 18 divided by 27 equals 0.666666, repeating. The 6 is going to repeat forever, so let's just put equals 0.6 repeating. Put the little bar above the 6 because the 6 is repeating. Good. So 0.6 bar, and over here 2 over 3 can be written as 2 divided by 3, which equals, and I'm going to tell you right now without using the calculator, that is also 0.6 repeating. 0.6666, 0.6 bar. All right, well, they are the same. We've done this question correctly because when we divide the top by the bottom, we get the decimal equivalent of 0.6 bar, and we get the decimal equivalent of 0.6 bar. That means these two are equal to one another, the 27 and the 18. Sorry, the 18 over 27 and the 2 over 3, they're equal because they have the same decimal amount. That's how you check your work. Let's do one more. 18 over 27, again, using a different technique. Now they're saying you do not have to use the greatest common factor. They're saying now you can use any common factor. That's true. You don't have to go ahead and do all this factoring work that I've done. It's helpful to do it, especially with huge numbers. If you're dealing with really big numbers, then you use that technique. But if it's just a small number over a small number and you want to get to the answer quickly, you can just use any factor. Here's what it looks like. We have 18 over 27, and just choose any factor that you can see would work. 1 doesn't go, 2 doesn't go. Well, 1 goes, it doesn't help. Let me show you that. 1 goes into both, but divide the top and bottom by 1, and you get the same number. 18 divided by 1 is 18. 27 divided by 1 is 27. So we haven't helped ourselves. We've wasted time. How about 2? Nope, 2 doesn't go. 3. 3 does go. Let's go and divide the top by 3. Let's divide the bottom by 3. And as a result, 18 divided by 3 is 6. And 27 divided by 3 is 9. Good. That looks simpler, but it's not done because there is numbers that go into the top and bottom. 1 goes into the top and the bottom, but we're not going to use it. It doesn't help. 2 doesn't. 3 does. So 6 divided by 3, 9 divided by 3 is, on top, 6 divided by 3 is 2, and 9 divided by 3 is 3. So we have 2/3, and we arrived at that answer. It's the same answer. So this technique works, and you might actually find that this is faster at times. But, sometimes it's not, just depending on the size of the numbers on top. All right. Either way, you can use either of these techniques, whether you're just going to start factoring and keep factoring till you're there, or whether you're going to identify the greatest common factor first and then factor by that amount. Both ways work. Both ways would get you full marks in your work and in your tests. Thanks for watching. Have a great day.